Hello and welcome to this video that demonstrates BUT4Reuse tool developed by Sorbonne University for work package 4 of Revamp project. We will talk in this video about the improvement of the variability identification and core asset construction in C and C++ variants. In general, BUT4Reuse is a tool for software product line extraction from legacy variants. The input of BUT4Reuse is a set of software variants. Then, using BUT4Reuse, you can perform several engineering tasks on these software variants, such as feature identification and naming, feature location, feature constraint discovery, feature model synthesis, and reusable asset constructions. As well as you can visualize different steps done by BUT4Reuse. The last version of BUT4Reuse is improved in 3 points. The first one is the understanding of variability dimensions in C and C++ source code by parameterizing the adapter of BUT4Reuse. The second one is the improving of variability identification in C and C++ variant, for example, by identifying variability at the statement level. The third one is related to the constructing of the 150% of C and C++ core assets using annotations of pure variants and ifdef. We developed a demonstration example of for variant of C++ of a vending machine family using the clone and on approach. During the clone and on of these variants, we introduced several variability dimensions related to folders, source code files, methods, and fields. The first variant composed of two main features, open closed compartment and free soda. The second variant is composed of two features that are open closed compartment and paid soda. The third variant is composed of three features, open closed compartment, paid soda, and cancel the order. The fourth variant is composed of four features, open closed compartment, paid soda, cancel order, and paid tea. To re-engineer these variants using BUT4Reuse, let's create artifact model. You can rename the artifact model as you want. In our case, we rename it to vending machine. Now we select the root of the source code of these variants. Drag and drop these folders to the artifact model. Let us see the preference page of BUT4Reuse. We can parameterize the C and C++ adapter. If you want to parse all source code elements, or if you want to specify specific set of elements, such as packages, header files, source code files, include tags, methods, and for methods you can specify the similarity between the elements of this method, the modifiers, the return type, the name of the method, the parameters list, and the body of these methods. And you can specify for each of them to similar, different, or ignore. You can also specify how to measure the similarity between the bodies of methods to consider the order of the statement or not inside these bodies. You can define the minimum threshold value of the similarity and the maximum threshold value of the similarity between the bodies of methods. You can specify to consider the fully qualified names or only the first name of the source code element. And if you want to analyze the textual comments. In addition, you can specify to whether detect the structural dependencies between the identified feature or not. Let us analyze the variability at the method level. To detect exact cloned methods, we put minimum and maximum similarity between bodies to 100%. Select feature identification. Choose the C and C++ adapter. BUT4Reuse has several windows to show the result from different perspectives. General metrics, constraint discovery, visualizer, the visualizer menu, word cloud, now with BUT4Reuse you can visualize graphs, statistics of the generated block. We have 4 common blocks of exact clone methods. Content of block 3. To see the content of block 1. Artifact oriented statistics. Shared element of free soda variant. We have 2 artifact exclusive blocks. Elements of block 4 represent about 18% of the free soda variant. Change the preference of BUT4Reuse. Select parse all elements for re-engineering. Feature identification. You can also generate the graphs based on parsing all elements. And use word cloud to rename the blocks based on the most common tokens in the source code of the block. Let's rename block 0 to soda open close compartment. Click on rename. After renaming all blocks, let's create feature model of these blocks. And this is the resulting feature model, in which we have 6 identified features and 6 required dependencies between these features. Before constructing core assets, let us choose the type of annotation. You can select pure variant, ifdef, or define your annotation. Now let's construct the core asset with annotations. This is the folder of the constructed core assets. Annotations are inserted in the source code. The implementation of the T feature. The annotations confirm also the .h file. Construct reusable core asset using ifdef annotations. You can see ifdef annotations are inserted inside the source code. As well as in the .h files. Thank you for watching this video. You can find more details about BUT4Reuse in the website. Also, don't hesitate to contact us if you have any question.